you do usually, the first thing you do is you blink a LED, and the second thing is you communicate on the RS-232 port. On the DS, we will not have this capability. And one of the very strong aspects is that it's got this legacy bus, the so-called slot 2 bus. This one is already hacked, but when you're familiar with the DS, this front port that you hardly use anymore, that's for compatibility with advanced Game Boy Advance games. And being compatible with Game Boy Advance, it means that you will be able to use all the documentation that people has accumulated year over year concerning the Game Boy Advance. And that's very important because this means that you have a very nicely documented bus on which to play with. The games will be loaded on the so-called slot 1 port, so that's the port on which you're used to inserting your game cartridge. And what you will need, the only piece of hardware that you will need to access all these demonstrations I'm showing you is this kind of cartridge, which allow you to put software on a micro SD card, and this piece of hardware will load the game or the program from the micro SD card for playing on the DS. So all our programs will appear as games for the DS. And in my case, I bought the one from M3. You have a whole collection of these pieces of hardware available on the web. It costs about 25 euro. So the total investment in what I'm showing you is having a game console and 25 euro buying one of these cartridges. And the objective that I set to myself is I want to be able to control hardware, and I want to observe my environment. So I want to acquire data from the Nintendo DS and transfer this data through the Wi-Fi link. That's my objective. I want to build basically a robot able to sense its environment, control, let's say, motors for motion, and all this has to be done through Wi-Fi link. That's my purpose. If you want to start such an ambitious project, you will not start with everything new. So arguably, nowadays, Linux is the most commonly piece of open source operating system. So let's start with Linux. Sorry for BSD guys here. We have already made a port of Linux, and actually UC Linux, Micro C Linux, the port of Linux to MMU-less processors. And this port of Linux for the Nintendo DS is called DS Linux. So you have a nice ready-made pre-compiled image. Download this image and compress it on your micro SD card, and you have your Linux running. It looks very nice. You have a virtual keyboard on the touchscreen. You have a console appearing on the top screen, and you have a running operating system on your Nintendo DS. And the first time you type a command, you get out of memory. But nevertheless, we have a running operating system which we're familiar with. It gives you all the interfaces you're familiar with, and it runs on an emulator. There is an emulator called, I don't know how they pronounce this, Desmume, I don't know, DESMUME. It's an emulator that runs on Linux and Windows at least. And you can see here DS Linux running on the emulator very nicely. So even people who do not have access to the game console itself can always play on the emulator. And for debugging purposes, when you are in a trial and error state, it's always nicer to try the emulator rather than removing the cartridge, loading your program, putting your cartridge back, rebooting the DS. It's always time-consuming. So as a very simple example, when you start the DS, you get your shell, and you have your keyboard, so you can type cat proc CPU info, you can free your memory, you can check the state of your operating system, and you get the devices that you're familiar with, such as a frame buffer. So let's get started with frame buffer. Remember, I want to acquire data, and I want to display this data that I acquire. So I will need a way to plot points. So the first thing I want to know is, will I be able to plot points on the top screen? The conclusion is, DS Linux is compatible with UC Linux, which is compatible with Linux. So your dev-fb0, your frame buffer device, is compatible with your usual frame buffer programming technique. So you open dev-fb0, you input-output control to generate a few of the properties of your of your frame buffer. You mmap this area, so you take that many pixels in a pointer towards the memory that stores the video frame buffer, and you're ready to write into this location the color that you have computed as 5 red, 5 green, and 5 blue bits. So it's very simple. You have a pointer to a memory map, and you write to this map all the pixels, one after the other, that you have computed by reading a bitmap image and computing each one of a color using this formula. So that's very easy. It's simply masking. And in order to check that our frame buffer access is working properly, just read a ppm image. As a random image, you can take the boot splash screen of your Linux box and display it on the NDS, and the yellow appears yellow, the black appears black. So indeed, we know how to write on the frame buffer, and this does indeed look like a penguin, so it's all working very well. So you have access to all these /dev, /proc devices that you're familiar with if you're a Linux programmer. So that will make our access to the Nintendo DS very easy with this familiar environment. Now, I told you that we have access. Software is only half of the topic of embedded device development. And let me remind you a little bit how hardware is accessed, and more specifically, how a CPU accesses hardware. This is something that people hardly know anymore, because with all these PCI buses, all these serial buses, you hardly have access anymore to the CPU. And what's really nice about the DS is that the slot 2, so this front slot here, is actually a direct access to the bus, or nearly direct access to the ARM9 CPU bus. And as a reminder, a bus is simply a series of signals, so it's a few wires, one next to the other. And all processors, to my knowledge, are based on the same architecture, the same basic architecture, which is a data, an address, and a control bus. The data bus tells you what you are transferring to your peripherals. The address bus tells you where you are transferring. Basically, if a CPU is connected to RAM, to ROM, and another few peripherals, let's say latches for blinking LED, for connecting LED, the address space means that in the first half of my address space, I will have the ROM. In the second quarter, or the third quarter, I will have the RAM. And in the fourth quarter, I will have the latch. So the address tells you where you are fetching or storing data. And finally, you have to tell the peripherals, what are you doing? Are you writing to the peripheral? Are you reading from the peripheral? Are you requesting an interrupt? Or are you listening to or is the peripheral requesting the CPU attention for an interrupt? This is done through the control bus. So you have a few control signals, which are, a signal is simply one wire, a bus is a multitude of wires. In the case of a Nintendo DS, the address bus is 20-bit wide, so this means that you have 24 wires, one next to the other. It's a 16-bit bus, meaning that you have 16 bits, one next to the other, 16 wires, one next to the other. And as is done in most time display of the signals, this is the time evolution of these multitude of signals. This means that the chip select is going from a high state to a low state. The symbol behind the chip select means that it's active low, so going down means that it's active. Read and write will go low, for example, when you are reading or writing, so this states that you are performing one of these accesses. And in the beginning, you have one thing that is a little bit awkward about the NDS, and it's something that you will find in most modern CPU, is that you have pin multiplexing. A given pin will have multitude of functions. In the case of the NDS, 8 of the 16 data bus pins are multiplexed with the address bus. This means that when your read or write bar signals are high, you know that on your data bus you actually have an address because it's multiplexed. It will have 2 functions.